Here is a question on general organic chemistry. Read the question carefully and think about the answer. Let us solve it step by step. Let us first understand the key concept here. Molecular polarity arises from an uneven distribution of electron density, resulting in a net dipole moment. Among the given structures, the one with the greatest separation of charge, or intrinsic bond dipoles that add constructively, will be most polar. Moving on to the next step. Analyze option A. A benzene ring fused to a cyclotetotrene COT ring. COT is non-planar and non-aromatic, tub-shaped, 8 pi electrons, anti-aromatic if planar. When fused to benzene, there is some charge transfer, but the overall molecule has relatively low polarity due to the symmetric hydrocarbon framework. Moving on to the next step. Analyze option C. Naphthalene. This is a symmetric, fully conjugated, planar polycyclic aromatic hydrocarbon. Due to its high symmetry, bond dipoles cancel, and the net dipole moment is essentially zero. Naphthalene is nonpolar. And for the final step, analyze option D. A bicyclic structure with explicit positive and negative charges on different carbon atoms. While this appears to have charge separation, these are formal charges drawn on what may be a zwitterionic species. However, in context this structure seems unusual and the charges may represent a specific resonance or strained system. Analyze option B. Azulene. Azulene is an isomer of naphthalene consisting of a fused 7-membered ring, tropylium-like, electron-poor, and a 5-membered ring, cyclopentadiene-like, electron-rich. The 7-membered ring tends to be electron-deficient, partial positive character, and the 5-membered ring tends to be electron-rich, partial negative character, because the 7-membered ring wants 6 pi electrons, aromatic tropylium cation, and the 5-membered ring wants 6 pi electrons, aromatic cyclopentadienyl anion. This cross-conjugation leads to a substantial ground state dipole moment of approximately 1.08 d, directed from the 7-membered ring toward the 5-membered ring. This is remarkably large for a pure hydrocarbon. Compare all options. Naphthalene C has ~0d dipole. Azulene B has ~1.08 d. The COT-benzene fusion A has some polarity but less than azulene. Option D with explicit charges might seem polar, but azulene's intrinsic ground state polarity from its aromatic subunit charge distribution is well established and is the classic textbook example of a polar hydrocarbon. Why other options fail? A. The fused COT-benzene system has some asymmetry but lacks the strong aromatic driving force for charge separation that azulene has. C. Naphthalene is symmetric and essentially nonpolar, dipole 0d. D. While it shows formal charges, azulene's delocalized ground state polarity is the chemically recognized answer in this context. Therefore, the correct answer is B. Therefore, the correct answer is option B.